Very good morning, students. Today I am going to start Unit 1, that is Electrochemistry and Batteries. In the first unit, we are having two subunits. One is Electrochemistry and Batteries. But now I am going to start the first subunit, that is Electrochemistry. And in this session, I am going to explain you the introduction topics and the basic concept of electrochemistry. And let us start the session. This is Unit 1, Electrochemistry. Maybe in the intermediate level, you have seen what is electrochemistry. Electrochemistry is the study of production of electricity from energy released during spontaneous chemical reaction and the use of electrical energy to bring about non-spontaneous chemical transformation. Here, electrochemistry is the study of production of electricity from energy released during spontaneous chemical reaction. That means electricity is producing from the chemical reactions. That means chemical energy is converts to the electrical energy. Yes, how the chemical energy is converts to the electrical energy based on the chemical reactions. Due to the chemical reactions, electricity is producing in the electrochemistry, and also the use of electrical energy to bring about non-spontaneous chemical transformation. Here also electrical energy is converts to the chemical energy. That is mean by the use of electrical energy to bring about non-spontaneous chemical transformation. That means by applying electricity, the chemical reactions are takes place. Yes. So this is electrochemistry is nothing but it is the study of interconversion of electrical energy to chemical energy and chemical energy to electrical energy. How electrical energy is converts to chemical energy and chemical energy is converts to electrical energy, that we will see in the electrochemistry. So now let us see the basic concept of electrochemistry, types of materials. But before going to see the types of material, we know that every substance or every material is not passing electricity. Few materials are passing electricity, and whereas few materials are not passing electricity, and some materials are passing electricity partially. So based on that, materials are classifying into three types. Based on the ability of flow of current, materials are classifying into three types. Those are conductors, insulators, and the semiconductors. So let us see what is conductor, semiconductor, and insulator. Just let us recall what is conductor, semiconductor, and the insulator. So you know what is mean by the conductor. Conductor is nothing but any material which is able to pass the electricity, which is capable to pass the electricity, that is called the conductors. Material capable of carrying electrical current, that is material which has mobile charge carriers. That means if any material is having the mobile charge carriers. So what are the mobile charge carriers? What is mobile? Mobile is nothing but mobility or movement. If any material is having the particles which are movement, which are mobile, those type of materials are passing electricity. That means those materials are having the mobile particles. Mobile particles are nothing but electrons or ions. So due to having electrons and the ions, those materials are able to pass the electricity. So that is mean by the conductors. A metal which is very good carrier of electricity is called conductor. So any material which is able to pass the electricity, those are called the conductors. So let us see what are the examples of conductors. Examples: metals, liquids with ions. So here all metals, almost all the metals are able to pass the electricity except mercury. along with the metals. Liquids with ions, any liquids which are containing ions are able to pass the electricity because ions are the mobile carriers there. I said now here mobile charge carriers. Here mobile charge carriers are ions here, the liquid with ions. For example, water, molten ionic compounds. Here molten is nothing but which is in the solid, semi-solid form, that is in the paste form. So those are able to pass the electricity. Along with that, plasma, copper, aluminum are the good examples of conductors. So here all these are the examples of conductors: metals, liquids with ions, plasma, copper, aluminum, and these are the examples of conductor. So simply what is mean by the conductor? Conductor is nothing but a material which is able to pass the electricity due to having mobile charge carriers. Here mobile charge carriers are nothing but either electrons or ions. Here electrons and ions are acting as the charge carriers. These are carrying the charges and these are moving. Due to moving or due to mobility, the materials are passing electricity. That is mean by the conductor. Now the next one, insulators. Insulators are also called as the non-conductors here. Non-conductors are nothing but it is opposite of conductors. We know what is mean by the conductors. Conductors are nothing but the substance or the material which is able to pass the electricity. So what is non-conductor? Non-conductor is nothing but it is opposite of conductors which are not able to pass the electricity. Yes. So material with no or very few free charge carriers and do not pass electricity. Yes. So whereas conductors are having the free charge carriers, but whereas insulators are having less number of free charge carriers, or these are not containing any free charge carriers, mobile charge carriers. So due to lack of mobile charge carriers, these are not able to pass the electricity because there are no particles are moving in the non-conductors. There are no mobile charge carriers. So due to lack of mobile charge carriers, insulators are not passing electricity. Example, quartz, most covalent and ionic solids, plastics, glass, wood, mica and paper. Here all these are the best examples of insulators. And the last material, semiconductor. In the name only we have semiconductor. It is passing electricity but semi, that means partially. A semiconductor material is one whose electrical properties are lie in between those insulators and the good conductors. So in semiconductors, here these are able to pass the electricity partially. So these are lying between the conductors and the non-conductors. These are lying between the conductors and the insulators. So those are called semiconductors. Those are able to pass the electricity partially. So maybe you heard about silicon semiconductors, silicon germanium semiconductors, silicon boron semiconductors. Yes. So these semiconductors are able to pass the electricity partially. So these are the best examples of semiconductors. Carbon, but not graphite, only diamond. The graphite is the best electrical insulator. Silicon, germanium, tin, gallium arsenide, indium phosphide, silicon carbide, cadmium selenide, boron nitride, aluminum nitride, gallium nitride, and indium nitride. So here all these are the best examples of semiconductors. Yes. So now you know what is mean by conductors, insulators, and the semiconductors. Conductors are passing electricity. Insulators do not pass electricity. Semiconductors, which are passing electricity partially, which are lying between conductors and the non-conductors. So now let us see the next topic, that is types of conductors. So we know how the conductors are exhibiting conductance due to the mobility of mobile charge carriers. So already we know what are the mobile charge carriers. Mobile charge carriers are electrons and the ions. Yes. So some materials are able to pass the electricity due to the mobility of electrons, but whereas some materials are passing electricity due to the mobility of ions. In every material, there is no electron and ion moving simultaneously. Yes, so either electrons are moving or ions are moving in conductors. So based on the nature of mobile particle, conductors are classifying into two types. Types of conductors. The conductors broadly classified into two types. One is called metallic conductors and other one is called electrolytic conductors. There are two types of conductors, metallic conductors and the electrolytic conductors. So let us see one by one. The first one, metallic conductors. Metallic conductors are also called as electronic conductors. I will explain you later at the end of metallic conductors why we are calling metallic conductors as electronic conductors. Yes, in metallic conductors, flow of electricity takes place without the decomposition of substance. Here decomposition is nothing but breaking. So without decomposing the substance, the material is exhibiting conductance. In metallic conductors are the electronic conductors. Flow of electricity is due to the flow of electrons only. That is, there is no flow of matter. Here, matter is not flowing or moving from one place to another place. Here, only the electrons are moving from one place to another place. So, due to moving electrons from one place to another place, the materials are exhibiting conductance. In electronic conductors are the metallic conductors. In addition to metals, graphite and certain minerals also conduct electricity due to the presence of free electrons in them. Yes. So here I said the graphite is the best electrical conductor, but whereas the diamond is good electrical insulators, but sometimes it is acting as the semiconductor. Yes. So in graphite, it is exhibiting conductance due to the mobility of free electrons. Hence, they are collectively called as electronic conductors. So I said now, metallic conductors are also called as electronic conductors because due to moving the electrons from one place to another place in the material, metallic conductors are also called as the electronic conductors. Metallic conductors decreases with increase of temperature. Yes, here this conduction is decreasing with increasing temperature. If temperature is increasing, what happens? Metallic conductance is decreasing. But why? The metallic conductance is decreasing by increasing the temperature. Yes. So what happened here? By increasing the temperature, here the kernel starts vibrating. So maybe you heard about kernels, but before going to see the kernels, maybe you know what is the outer shell and the inner shell. Here outer shell is nothing but the valency shell. Valency shell is nothing but the outer shell. So every atom is having the inner shell and the outer shell. But here the atom is not having the outer shell. That means the atom without outer shell is called the kernel. Yes, the atom without outer shell is called the kernel. That means this atom is having the nucleus and the protons. Yes, but it is not having the valency shell or the outer shell here. Yes, so that is called the kernels here. These kernels are starts vibrating. So when these kernels are starts vibrating, what happens here? Inside the electrons also starts vibrating. So when the electrons are vibrating, what happens? There is repulsion. Yes, there is repulsion between the electrons. So when there is a repulsion, the conductance is decreasing. That's what we are explaining here. Metallic conduction decreases with increase of temperature. This is because kernel starts vibrating, which produce hindrance in the flow of electrons. Hindrance is nothing but stopping. That mobility is stopping due to the repulsion. Yes, so due to the repulsion, the conductance is decreasing by increasing temperature in the metallic conductors. So simply, metallic conductors are nothing but the conductors which conducts electricity due to the mobility of electrons. So the metallic conductors are also called as the electronic conductors. Example of metallic conductors are all metals. Here all metals are comes under metallic conductors. So now let us see the next type of conductors, that is electrolytic conductors. Electrolytic conductors are also called as the ionic conductors. In electrolytic conductors, flow of electricity takes place by the decomposition of the substance. But we have seen now metallic conductors. In metallic conductors, there is no decomposition of the material. Material is not decomposing, but without decomposing the material, the metallic conductors are exhibiting conductance. But in electrolytic conductors, the material is decomposing. Due to the decomposition of material only, the electrolytic conductors are exhibiting conductance. So in electrolytic conductors, flow of electricity takes place by the decomposition of the substance. This substance is also called as the electrolyte. Flow of electricity is due to the movement of ions, and hence there is flow of matter. But in the previous, in metallic conductors, there is no flow of matter. But whereas in electrolytic conductors, due to decomposition of the substance, there is flow of matter. Here matter is flowing, matter is moving in electrolytic conductors. So here what is moving from one place to another place here? In electrolytic conductors, due to decomposition of the substance. Due to decomposition of the material, it is giving the ions. So what ions it is giving? It is giving the cations and the anions. Yes, these cations and the anions are moving from one place to another place. So due to moving the matter, here what is the matter here? Matter is the cation and the anion. Due to moving the cations and the anions, it is exhibiting the conductance. So now let us see what are the examples of electrolytic conductors. Solution of acids, bases and salts are the examples of electrolytic conductors. So you know what is meant by the solution. It is the mixture of solute and the solvent. That means solutions of acids, acid solutions, bases solutions and the salt solutions. Here all these are the best examples of electrolytic conductors. The electrolytic conduction will not occur unless the ions of the electrolyte are free to move. But when the ions are free to move in electrolyte, when electrolyte is decomposed. Yes, when electrolyte is decomposed, then only ions are starts moving, then it is exhibiting conductance. So those are called electrolytic conductors. The electrical conductance increases with increase of temperature. But whereas in metallic conductors, the conductance is decreasing by increasing the temperature due to mobility of the kernels, due to vibration of the kernels, the conductance is decreasing in the metallic conductors. But whereas in electrolytic conductors, conductance is increasing by increasing temperature. Why? By increasing temperature, the decomposition also increasing here. So when the decomposition is increasing, what happens? By increasing the decomposition, number of ions are increasing. By increasing the number of ions, conductance also increasing, because these are the mobile charge carriers. Number of ions are the mobile charge carriers. So conductance is increasing in the electrolytic conductors by increasing the temperature. But here, all electrolytes do not ionize to the same extent in the solution. Yes. So every substance or every material is not decomposing in the same speed. Some electrolytes are decomposing slowly, but some electrolytes are decomposing very fastly. If some electrolytes are decomposing fastly, what happens? The number of ions also immediately increasing, the conductance also increasing immediately. But whereas few electrolytes are not decomposing completely. Some of the electrolyte is decomposing, but remaining electrolyte is not decomposing. So what happens when the electrolyte is not decomposing completely? The number of ions also will be less. When the number of ions are less, the conductance also less. Yes. So every electrolyte is not decomposing with the same speed. On this basis, electrolytes are broadly divided into two types. Those are called strong electrolyte and the weak electrolyte. So let us see what is meant by strong electrolyte and the weak electrolyte. Strong electrolytes are nothing but the electrolytes which are almost completely dissociating into ions in the solution are called strong electrolytes. Yes, here in the strong electrolytes, the electrolytes are decomposing completely to cations and the anions. That means 100% decomposition takes place in the strong electrolyte. That means the entire electrolyte is converts to the cations and the anions. So the conductance is more for the strong electrolyte. So example of strong electrolyte, simply remember strong acids, strong bases, strong salts. Here all these are the best examples of the strong electrolytes. Here NaCl, it is one of the strongest salt. KCl, it is also strongest salt. HCl, hydrochloric acid, strongest acid. NaOH, strong base, sodium hydroxide. NH4NO3, ammonium nitrate. Here ammonium nitrate is one of the salt here. This is one of the salt. This salt is the strongest salt. Yes. So these are the best examples of strongest electrolytes. So now the next type of electrolyte, weak electrolyte. Weak electrolyte is nothing but the electrolyte which do not ionize completely in solution are called weak electrolyte. In the strong electrolyte, I said you, it is decomposing 100%, but whereas in weak electrolyte, it is not decomposing 100%. It is decomposing around 40 to 50% or 50 to 60%. That means it is decomposing partially. So due to decomposing partially, the entire electrolyte is not able to give complete cations and the anions. Yes. So the conductance is less for weak electrolyte. For example, acetic acid, that is the weakest acid, carbonic acid, boric acid, hydrogen cyanide, mercurous chloride, zinc chloride, ammonium hydroxide. Here all these are the best examples of the weak electrolyte. But thus in case of weak electrolyte, an equilibrium is established between the unionized electrolytes and the ions formed in the solution. So maybe you know what is meant by the equilibrium here. Equilibrium is nothing but, so you will be having the forward direction and the backward direction reactions. There is forward reaction takes place and the backward reaction takes place with the same speed. That is called the equilibrium here. there is an equilibrium between the reactants and the products. Maybe you know what is mean by the reactants and products. Yes, before the reaction we are taking the reactants. These reactants are converts to the product after the reaction. Yes, so always reactants are at the left side, products are at the right side. There is a equilibrium between the reactants and the products in the weak electrolyte. So there is a partial charge on cation and the anion. But whereas in the strong electrolyte, there is no partial charge. For example, let us take HCl. In HCl, we are having H plus and Cl minus. But here in acetic acid, we can't write CH3COO minus H plus. In sometimes we are writing, but that is not a complete anion and the complete cation here. There's CH3COO partial negative charge and H partial positive charge. So that's the reason there is an equilibrium between the reactants and the products in the weak electrolyte. So there are two types of electrolytes. One is strong electrolyte and the weak electrolyte. Strong electrolyte is decomposing completely, but whereas weak electrolyte is not decomposing completely. So now I will give the definition of electrolyte. The substance which decompose by passing electricity. The electrolyte which decompose by passing electricity is called electrolyte. These are two types, strong electrolyte and the weak electrolyte. So now let us see the basic concept in electrochemistry. So now we have seen electrical energy converts to chemical energy is converts to electrical energy. So their electrical energy is nothing but electricity, but whereas the chemical energy is nothing but chemical reactions. Those chemical reactions are redox reactions. So now let us see what is mean by redox reaction. So here redox reaction is nothing but the reaction in which both reduction and oxidation takes place. The reduction and oxidation, the red stands for reduction, ox stands for oxidation. The reactions in which both reduction and oxidation takes place is called redox reactions. Here, just for remembering, so I'm giving the simple technique, oil and rig. Here oil is nothing but oxidation is nothing but loss of electrons. O is nothing but oxidation. I means is. L means loss of electrons. So simply oxidation is nothing but removal of electrons or loss of electrons. For reduction, so you can remember by remembering RIG, R-I-G. Here R is nothing but reduction. I is, G is nothing but gaining of electrons. So reduction is nothing but gaining of electrons. Oxidation is nothing but loss of electrons. Oil, rig. Oxidation and reduction must occur together. If there is reduction, obviously oxidation also takes place. There is no reduction alone, oxidation alone. Always reduction and oxidation both takes place together. That's the reason the reduction and oxidation combination reactions are called redox reactions. But there is no reduction and oxidation alone exist in the reactions. They cannot exist alone. So that is reduction and oxidation. So what is oxidation? Oxidation is nothing but loss of electrons. Oxidation is loss of electrons, oil. So let us see oxidation half reaction. I will explain you later why we are calling half reaction here. Oxidation half reaction, but we know oxidation is nothing but loss of electrons. Zinc is losing 2 electrons to produce Zn plus 2. By losing 2 electrons, it got the positive charge that is plus 2. Zn plus 2. The zinc loses 2 electrons to form Zn plus 2. So now let us see what is reduction example. Reduction is gain of electrons, that is Rig. Reduction is gain of electrons. So for reduction, I have taken copper plus 2. This copper plus 2 is gaining these 2 electrons. So whatever the electrons lost by the oxidation, those electrons are gained by the reduction. So this copper plus 2 is gaining these 2 electrons to produce copper. Yes, so it gets the neutral charge because initially it is having 2 positive. 2 positive is nothing but 2 electrons are deficient here. 1 plus means 1 electron deficient. 2 plus means 2 electron deficient. 3 plus means 3 electrons deficient. So now this copper plus 2 is having 2 electron deficiency. So it is gaining the 2 electrons to produce copper. That is reduction. So the Cu plus 2 gains 2 electrons to form copper. So now by adding oxidation reaction and the reduction reaction. So how you are adding 1 plus 2. So by adding 1 plus 2, you will get 3. By adding 2 plus 2, you will get 4. So same like that, by adding oxidation and reduction reaction, you will get the overall cell reaction. You will get overall cell reaction by adding oxidation and the reduction. So now let us add this reaction and this reaction. So when we add these two reactions, see here this is the reactant in this reaction and these are the reactants in this reaction. Now arrow and the products are Zn plus 2 electrons and here the product is copper. So by adding these two reactions, you will get the overall reaction. Now you need to add the reactants and add the products. By adding reactants and the products, 2 electrons gets cancelled here. Because left side we are having 2 electrons, right side also we are having 2 electrons. So those two gets cancelled. So by getting cancelled 2 electrons, we need to add the reactants Zn plus Cu plus 2, giving rise to Zn plus 2 plus Cu. So adding the reactants and the products, you will get the overall cell reaction. Yes. So this is redox reaction.